Uh, Hello again. Good morning, good afternoon. It's really good to see everyone again here. The topic of today's presentation and today's meeting, not presentation, is data access. So, of course, data analytics, data processing, understanding the data starts with getting the data somehow. And this is how this is where Datagrok helps you. So we, in short, can provide access to pretty much anything that is machine readable. So that includes all sorts of major databases, relational databases, non-relational databases, NoSQL databases, you name it. Then we can easily connect to web services, and that could be done in multiple flavors, whether we can connect automatically to OpenAPI specifications, and for anything else, we might need to write some custom JavaScript. Then we do work natively with a lot of existing popular data formats, and that includes I just realized I was not sharing my screen. Sorry about that. Yeah, I was clicking through the items on this panel. So at any time, you can go back to our website and just go to that access section and either click through the items or click on the learn more to get interactive help regarding what we will be talking about. But yeah, back to the content. We do support multiple file formats. That includes popular formats such as CSV, TXT, JSON, and others, but also tons of scientific formats. And we do have a system that can natively extend the platform to understand your very custom format, which is very handy, given that plethora of scientific formats around and different ones. Especially in the areas such as bioinformatics, it's really important. Then for relational databases, we can connect to them visually. We can interrogate their schema and browse the content of the database. Then we can connect to a lot of publicly available databases, and that list is growing. Finally, everything could be automated. More than that, as you will see during the presentation, behind the scenes, as we do things visually in the platform, there is a macro that is being generated that could be replayed at any time. So all the data ingestions and transformation steps that you are performing, they could be scripted and replayed back at any time. We will also take a look at some of the more advanced concepts, such as generating data from arbitrary functions or from scripts using Python or R, which are in turn functions. So from the platform's perspective, there is very little distinction, but still it's good to know. And please, as usually, do interrupt me at any moment. It's great to have a lively discussion. And are there any questions or suggestions at this point? Yeah, let me know if you want us to explain something in particular in more details today. All right, so let's get started with a real demo. We are using our public instance today, and I see representatives from multiple companies. As you know, you have your private instance within the company, which can connect to the company-specific databases. But today we will be demoing it on the public instance. So let's let's start with the beginning, opening files. So one of the easiest way to open a file is to simply drag and drop it from your file system, like I will do in a second. Go start dragging. There is a message saying that you can drop it here, and just drop it. In a second, it's open and available in the platform. We will demo different data ingestion steps, like I mentioned. This one is unique in a sense that that's the only one that could not be reproduced automatically. Since I've just drag and dropped a file from the desktop, of course, the browser does not have access to my file system. This step cannot be easily reproduced automatically, but the rest of them are reproducible. Presumably, you know a little bit about the platform, so we will not be stopping today on the visualization aspects and different aspects. There will be separate presentations related to that. Today, the focus is on data access and data reproducibility. Additionally, files could be opened in a different manner. There is that whole section for data access on top with a file open icon. So click on it and explore different options. It all starts with files living in a file system that is accessible from a server. So what's happening behind the scenes? The Datagrok that runs in my browser is talking to the server, which is installed on Amazon, and that has access to a number of folders that are shared. In order to add a share, we would click the new file share, and then we can connect to multiple types of file storages, or popular types such as Dropbox, Google Cloud, S3, and others. And then depending on the storage type, you are asked to enter the login credentials, and essentially, once everything is entered, the connection will be created. We will not be doing that particular step, but let's see the credentials for one of the connection. So this is a mounted folder on our server. It has a files connection. The platform allows us to explore the file system just like you would do regularly with your file system browser. There is a hierarchical tree. The files could be drag and dropped from your desktop if you want to upload them, and a lot of the typical stuff is available. You can right-click and see available actions. So it's a file management platform as well. You can control your file system. And of course, it is all covered by the system of access privileges. So a connection could be shared to multiple individuals or multiple groups with the appropriate sets of privileges. What we are mostly interested today, though, is accessing the data. By the way, the way the browser is structured is that on top it contains a list of files and folders in it, and of course you can navigate in a usual manner. But then there's also the preview of this current folder, which could be turned off if you want to. By default, it shows us what takes the most space. So it uses a tree map which is area coded by file size. In this particular case, for instance, we see that the folder with the name CSV occupies most of the space. Bringing the data in is super simple. By the way, as you can see, as we click on a file, the content gets shown interactively. But not only the content, in this particular case, it's already completely available in the system as tabular data. So you can visually inspect the content on a columnar level, or essentially scroll down and see pretty much anything. To bring it to the platform, you would either double-click or right-click and select Open. This particular action, as opposed to the action when we drag and dropped it, is replayable. So behind the scenes, in the console, and I'm going to Windows console, we see that an action was generated with the name open server file and a path to it. A path is qualified with a namespace. What is great about it is that it could be replayed at any time if we just copy-paste it or some other script.
Andrew, this is JP. I have a question, if that's okay.
Yeah, of course.
Thanks. Just back real quick. With the view of the data of the file system, quote unquote, that you have, is there any other metadata associated with each file or folder that is present, or do you have to dive in? So I would like to see maybe the last modified date, or who owns the file, some metadata about the listing up top. Do you have any of that at this time, or do you have to dive in to find that information out? Thank you.
Thanks. Good question. That was probably supposed to be another big topic, another presentation just related to our metadata and files. So I'm glad you asked it. I'll give a short answer. There is a lot of metadata available. It is stored. It's probably not exposed at the moment, which we will change in the next day or two. More than that, we have a really flexible system for extracting metadata from files automatically. So imagine, and that's what I'm showing right now, imagine that we have files containing, for instance, pictures. We have a way to create scripts or essentially any functions that work against files. And all that they do is extract metadata. It could be something simple, like you mentioned, the date of modification or the author, but it could be something a lot more interesting. For instance, in this particular case, for pictures, we have some information coming from, this is a project called Apache Tika, and which is capable of extracting a lot of metadata from files. So in this particular case, as you can see, we get metadata about how many, what's the resolution of the image, a number of components, and other stuff. For different types of documents, there are different metadata components available to us.
Would I be able to tag a file with keywords, so to aid in searching to find something specific? Thank you.
Absolutely, and that's exactly what the purpose of this system is. So we are not ready to demo it today. That was not supposed to be a demo of this functionality, but I'll give you a teaser. In addition to that rich metadata, which is sort of standard, and yes, you will be able to both tag it and search for it. We also support custom metadata extractors. So in this particular case, this is a Python script, which we can see by clicking on the I, created by us, which specifies the types of files it should work against and the type of metadata it extracts. In this particular case, in addition to metadata, it also provides an image So this is an image of some cell culture, and as you can see on this right side, the cells are segmented and also counted. And that becomes part of the metadata. That script will be invoked during our file indexing process, and it will live together with the rest of the metadata. And you will be searched for things like give me all pictures of cells created yesterday by JP with cell count greater than 50. Okay, so this is all coming. There will be a separate presentation, but indeed nicely into one ecosystem.
All right, thank you.
So our file exploration view not only can work with tabular data, but it also supports a number of custom visualizers for types, for file types, and also a number of different processors. So to give a preview of what it could do, yeah, for instance, this is an R file, and as you can see, it is not only editable, but also the code is highlighted according to the R language standards. And we have similar capabilities for essentially providing external viewer or editor for files. All right. If there are no questions regarding files, we'll go to our next topic, which is databases. All right. Let me close that view and another view. And we'll go to the databases. Datagrok provides a way to connect to pretty much any database right out of the box. We support probably 20 or 30 of them, and it's trivial to add a new connector, which we will cover during our developers segment after the user's presentation. Adding a new connection is easy. Similarly to file shares, you can just click on new connection. In a similar way, you would choose type of the provider. And then depending on the provider, different login credentials are required. The login credentials are kept in a separate secure vault in an encrypted way, which could only be encrypted with your login credentials. So we thought about that a lot. Also, all of the connections to the databases, as well as connections to file systems, they are also subject to privileges and security checks. So each connection, actually each shareable object, when you click on it, there is a panel called sharing. So expand it to see who has privileges and which ones. Well, that's if you have the privilege to look at the other's privileges, which I do. And it's easy to share it again with a particular group or an individual, and so provide the level of access needed. So once a connection is created, there are multiple ways to connect to it, explore it, and work with that database. So let's take a look just at the exploration, what we could do. Under each connection, we see a node called tables. It all depends on the provider. Some providers also support schemas, such as Oracle, so you would see another level of hierarchy. And these are all the tables. Well, the simplest way is to simply click on a table and expand the Content tab. By default, it shows the first 50 rows, so it's not going to take a lot of time. And I find it an incredibly useful tool for just checking what's in the database. And of course, the content is in our data frames and in our spreadsheet. So you can do some basic profiling on a column level right from here. If it was to contain some molecules or other user-defined type, you would also see the molecules rendered right here. So it's all very much live and interactive. You can go down a level and see properties for each column, in which case, in addition to some general information such as names, types, additional metadata, there is also a way to quickly inspect it. So behind the scenes, SQL queries are generated to calculate these values. Just basic stuff, minimum, maximum, other basic descriptive statistics. Another way to query the database is to visually query them. And there are multiple flavors to it. So let's take a look at one of the databases that we have. This is the famous Northwind database that Microsoft usually uses in their demos. So we've installed it on our server as well. It's a database representing some sort of sales, customers, orders, very typical for relational databases. So we will do a couple of visual queries against that orders table. So this is how it looks like. Some customer IDs, dates, order IDs, countries, cities, and so on. Let's right-click on it, and we'll do a visual query. So what this particular tool does, perhaps we should rename it to visual aggregation. It lets you create an aggregation query against that particular table really efficiently. So I'll say in advance, currently there is no functionality in this particular tool to join multiple tables. It is coming, but currently you can interrogate one table pretty efficiently. And of course, if you have access to the database, quite often you can create a view and then interrogate that view. So that's a workaround for not having the capability to join multiple tables in this interface. Building a query is easy. You would just add measures. So for instance, we want to calculate average freight. And as we build the query, the results appear instantaneously. So it's a nice way to query, for instance, databases that will not fit into the memory anyway, or for something where you know in advance what you're looking for. You can change any parameter of the aggregation by right-clicking on it and change either the aggregation type, in this case, well, I'm probably interested in the sum of freight and not the average freight, and column, which I will not change in this case. To group by different columns, use the rows aggregation. Let's group by country and then by city. One of the popular features when people query data is the ability to pivot this data, essentially put values in columns. So we support that feature as well. Put these columns in the columns field. What would be the good one? Well, I'm going to use some random column. That's probably not the best structure to query.
Yeah, and how do you bring extra columns without without them being involved in pivoting or grouping?
But they should be either part of the measures, right, or part of the keys. Yeah, so rows, so these are essentially keys. And measures, yeah, they become values, aggregated values, right? There's only two ways to add columns.
Yeah.
I'm afraid that was the wrong query to run. We can still go back while this query is running and keep working with the platform, but I'll just start with a fresh one just in case. Another way to query the database is to another popular way of querying a database is the one when you start with a particular table and then you join different attributes using the left join that are related to that table. So, for instance, we have this is actually a database that represents the metadata in Datagrok. And as you can see, we have a lot of metadata. So let's see what we have. In it. Yeah, we can click, of course, on a table to see the content. So these are predictive models. Yeah, they all have some information, IDs, performance characteristics. Some of the information, of course, is stored in the form of ID. So it's a reference to the user who was the author of that predictive model. So what if we want to retrieve all of that information all at once? So for that, we have a slightly different tool. And again, we do plan to combine these tools in the future, but currently they're different. That lets join the tables easily. So in order to do that, we would do a build query. And what happened at this particular stage is that our platform figured out the schema of the database, and starting from that models table that we clicked on, it added all the tables that could be reached by following the foreign keys. So in our case, if we wanted to have the name of the model and then the method of the model, and we can see the results right here. Let's combine it with the, for instance, first name of the user who created it. And yeah, we see it immediately. And it's trivial to combine it with other tables as well. What I forgot to mention when I was showing the visual query previously is that both of these query builders provide a way to construct, to save, to persist that query that we were generating visually. So yeah, there is an option to add this particular data frame to the workspace and keep interrogating. And another option is to save it as a query. In this case, we see, we give it a name, and we can also modify the SQL query that was generated behind the scenes. So it gives you that extra option to fine-tune the query. Additionally, there is an option to introduce parameters to that query, which I will cover right now. Any questions regarding these query builders? Okay, great.
Yeah, well, I've got one actually. Yeah, Nick here. In the previous thing where you were showing, for example, the different aggregations, the functions you've got there, are they part of Grok, or are they the aggregation functions available natively on that database?
Fantastic question, and yeah, I forgot to mention that. So we do have an open source project which is called Connectors. It is part of our open source repository. You are probably aware of the packages folder that we have, but this one is different. So this is the open source project, which is Java-based. It contains essentially all of the source code for our database connectors. And there is a way to define a custom aggregation function per each database, per each provider, which is extremely useful. So, for instance, Postgres database exposes some sort of GIS, Geoinformation System functions out of the box, which our driver exposes, and then the user get an option to aggregate it using these functions. Other databases, such as, for instance, SciDB, provide a number of complicated scientific functions which could be used for aggregations. They could all be exposed in the providers. So there's a way to do it, and I believe Vasily will later explain it in more details. And then these types of aggregations that the data provider exposes, they get picked up by our user interface, and you see the option to aggregate it if you are using that particular provider.
Cool, thanks.
All right, let's let's make a smooth transition to parameterized queries. So we'll still explore our databases, our favorite Northwind query, and let's see one of the queries. So these items with the green arrow are queries, similarly to the one that we almost saved. So let's explore this particular query. It is a SQL query, but what's interesting about it is that it defines some additional metadata on top of it. So if you attended previous meetings, or if you worked with the platform already, you are familiar with that concept. We use it throughout our platform. This is a way to add parameters to functions. And in our case, SQL queries are also functions which are discoverable by the platform, and they could be used in different contexts. So this particular function defines a number of different parameters, which are then used in that query. So, of course, if there is an employee ID parameter, then we would use it like that, with the sign preceding the name. So it's a very short way to define, customize your queries. Really, this is as small as it could be, and then each parameter is also annotated. Also, let's see what happens when we run it. So the UI is being generated dynamically from that little snippet of text. And by itself, it is almost like a mini application that you can easily expose to the end users. It's also pretty smart with the way parameters are treated. Not only there are input boxes where you can enter the value, like with employee ID. We also support a concept that we call parameter patterns. Yeah, in this case, the type of the parameter is always string, meaning that it could be entered by hand, and you can enter pretty much anything. But then you would specify a pattern with the real data type. What that means is, first of all, this is a free text field where we can enter things, expressions, free text expressions, for instance, greater than 55. And by the way, you see the dynamic interactive validation. So greater is an invalid value, but greater than 44 is a valid value. So what's happening on the client and on the server? Let's see how this particular parameter ship via is used. As opposed to the first parameter, which was simplistic, it was just using a regular parameter in a prepare SQL statement. This particular one is written in a different way. So you would define it by using the name of the parameter, and then in parentheses, the column name. So this is the column name from that orders column. And what's happening behind the scenes is that depending on the expression entered in this field, the database engine will generate different type of the SQL query based on the stuff. So we can do things like ship via in and then different values in parentheses and other stuff. By the way, you can click on the hamburger icon to see some suggestions or particular help for the search patterns. We support many of them, and they are also provider specific. And overall, it's an extremely powerful way of exposing information to users. You can enhance it on multiple levels, and really it becomes pretty sophisticated. In addition to patterns, we also support things like a list of predefined choices, which is a convenient way to populate a list, which could be either static or, in this particular case, they are dynamic. And they are retrieved by executing that particular SQL query against the same connection. We can also reference another queries in this created on the same level, which I don't think we have an example right here, but it's possible. And also, there is a way to provide suggestions for parameters. We probably have it in some other example, and I will not cover it in details. But how it works like and how it looks to the user, you start typing, for instance, ship city Philadelphia, and there is a function that accepts the current input of the user, and in return it suggests a list of possible values to autocomplete it with. And again, it for this particular case, the implementation is very simple. It will be a one-liner. So what I find really cool about it is that things that take developers sometimes a lot of time, right? So this autocomplete thing is you have to have your data access layer and particular UI and some autocompleter, and the events are asynchronous and stuff like that. You can implement here with really one line of metadata when defining a parameter. Any questions regarding parameters? Walter, I see your lips moving, but you're on mute.
Yeah, sorry, I was muted. So I like this capability, so that you basically can define the queries and you have them there with the data, kind of with the source schema that it applies to. Now, are there any features that allows you to do more of a high level? I'm thinking here of virtualizing something so that you kind of create the queries across multiple data sources. Is there such a thing or something like that, so that if you have data here in one database but some other data in another one, so that you could connect them? How would you do something like that?
Absolutely, that's one of the scenarios. So it's possible to, in that particular case that you mentioned, you would create 2 or more separate queries to different data sources, and then use them in a data job, which will essentially execute both of them, and if necessary, merge the results or just provide them as 2 different tables. So yeah, these kinds of transformations are completely supported. There are multiple ways to do it. It can be either completely done in using JavaScript in code, which might be convenient for developers, but probably not terribly convenient for end users. And we also have a specialized UI for building that sort of workflows, where you start on the left side with your essentially getting data, and through a series of transformations, you can use any function defined in a platform to transform it. And here we can do things like merging, joining, imputing missing values, or really using any function that you defined in Python or R or any other language. Today we will mention it briefly just for the sake of time, but there will be a separate presentation regarding that particular tool, which is pretty big.
Okay, thanks.
All right, so before we start the next topic, which will be transformations of the queries, so each query result could be transformed, I just wanted to show a slightly more complicated way for preparing results. In this particular case, let's take a look at the Campbell database. As you know, that's a publicly available chemical database. And we can do things like search for particular molecules in the database, either similarity search or substructure search, using the same concept that we have just introduced, parameterized queries. It's performed using a technology called database cartridge. I will not go into details here, but what it boils down to is that in the end, it's a SQL query with some special syntax, which is completely, it works really nicely with our ecosystem, where it's a SQL query with parameters. What we do here is we construct a SQL query that utilizes that SQL cartridge with a specified parameter, but a parameter in this case we annotated additionally, adding an information that while the data type is string, its semantic type is substructure. And in this case, when we execute this query, there is a completely different user interface. So we have a way to specify different input elements for building the UI for the parameters. In this case, well, this is a chemical sketcher. You probably guessed it. And it's building a UI for chemical search or for any other search for that purpose is just as easy. The same concept can be generalized to any other data type. That means that this particular cartridge is not deployed on that database, so the query failed, but the important part, it did right, the ones that we are interested in. Then, of course, once we pull down the results of the query, quite often it's important to transform them before the consumption and use different functions for that. So here, Alexander will walk us through different options. So Alexander, please take control.
Thank you, Andrew. Can you see my screen?
Yes.
Yeah, hi everyone. I will introduce our feature to transform query results. So, as you know, every function, everything in Datagrok is a function, and every function can be reproduced as it can be serialized to text script. And that's why we can transform query results. So, for example, that's a really simple query. It just gets all rows from table products, and I can subset it. I can use our transformation editor to execute any function against that query. For example, let's subset it. So I would like to get 4 columns and 20 random rows. So here is what I get. You can run pretty much any function that Datagrok supports. There are a lot of them here, but even more, each script can be also a function. So you can write a Python script that accepts table and produces a table, and it can be used as a transformation step. You can switch between transformation steps and see every stage of transformation. You can edit parameters, and you can delete steps and completely feel free to edit it as you want. I can even edit table as I normally do, but there is an exception. Users that who are familiar with Excel know that case that we don't keep selections, so I have to manually edit all of this, and that's all. This list of functions is curated, so we show here only a function that suitable for current operation. We show actions that suitable for current domain, for example, chemical actions. They also fully support all of chemical types, smiles notation, and so on. Everything that Andrew shown to us is supported here. So most of the operations you can do with the data in Datagrok, you can script them, and Datagrok will do it on table, on query execution. Let's take a look. So I select 3 columns and 4 rows. Let's save the table and then run it. As you can see, here is transform table. So this query completely took all transformation. So let me refresh it. We can get back to it. That's how it's done. You can use each function to in query transformations. And I guess that's all about it.
Alexander, can you output more than one table? I mean, is there any transformations that splits a table and creates more than one table?
That's a great question. In this UI, it's impossible because it's intended to transform only one table, but we have jobs. There is another user interface, and there you can use more than one table, join them, or transform how you want.
Okay, thanks.
Yeah, right. This tool was specifically designed to be a streamlined interface for things when you start with one query, with one table, and you just keep modifying it, which is probably the case for 90%, so we optimized for that. The other tool that I mentioned and Alexander also mentioned is a lot more complicated. It's similar to what, for instance, NIME or Pipeline Pilot is doing, but you have complete control over everything, and you can visually inspect every step and run steps in parallel, things like that. Okay, thank you, Alexander. Any additional questions on transformations? Okay, then let's go to our next topic, which is ingesting OpenAPI Web Services. In addition to all of the types of data sources that we mentioned, it's possible to use web services. And we can ingest them in multiple different ways. Well, first of all, it's always possible to write JavaScript code that will do exactly what you want to, exactly how you want to, since you have complete control. But for web services that provide an open API description, we have a solution that works out of the box. Just for the reference, OpenAPI, or sometimes referred to as Swagger, is an open specification that just defines the different methods or functions that a particular web service exposes, along with the parameters and other information such as how do you authorize against it, and so on. The specification is pretty complicated and it keeps evolving. We, I believe, did support completely specification OpenAPI 2.0, and now we are supporting OpenAPI 3.0. Not all cases are done. I'm not even sure if they could be done theoretically, but we do most of the usually used cases, and there is a way to intercept whatever you want and customize it if necessary. So quite often it's a useful tool to start with and then start tinkering with each particular method. So right now you are looking at the different collection of open API methods that we currently have in our repository. None of them were created manually. They were introduced by importing that OpenAPI or Swagger file. So this is actually, let's do it right now. Let me find it. Okay, so this is the YAML file. Oh, that's the extension YAML, which And that's how the content looks like. It's a YAML file that describes what the web service is doing. And now we will simply drag and drop it into our platform, and the platform will be smart enough to understand what that is. I'll just close web services just to see. We would drag and drop it. There is some processing, and then it says that a connector has been imported. Not only it has been imported, it appeared in the property panel. We can access it either here, or we can go through web services. Well, I did a little bit more than was needed. And that's the connector, probably this one, right, that was created by me 25 seconds ago. When we expand it, we'll see all the methods provided by that connector. So this particular one returns the current quality of the air in the US, I believe, maybe globally, probably in the US, since it's the zip code. So let's try to do something. So this is a function, just like a query or a script, which you can run. So we would run it. It has parameters, and again, the UI is generated automatically. Let's try to enter my zip code where I am now, and distance, if I remember this distance in miles. And we have a choice of what to return. Let's leave for JSON. I'm not sure what will get returned. Okay, so apparently we do need some credentials to use that web service. Vasily or Alexei?
Yeah, you can use that you already selected.
Okay. Yeah, I'm just gonna use another one where we have proper credentials installed. Yeah, let's try to do the same. By the way, this is a nice feature that I also forgot to mention. When the functions are invoked explicitly, use this watch thingy to access the parameters entered by you previously. So you see exactly what was used and when. In this particular case, we might want to just reinsert parameters by clicking on them. Saves tons of time. So let's see if something will appear now. Okay, great. And indeed, that's the current, well, last observed air quality around Philadelphia. It's as easy as this. But as people know, and I see Ed's picture on the screen, it's not always straightforward. Sometimes you do have to tinker with just because it's inherently complex things, and there are many different possibilities what can go wrong. Okay.
Or right. Not everything goes wrong there, Andrew. Some things go right on that. So
yeah, once in a while, yeah, we do succeed. Any questions on web services and Swagger? And of course, it goes without saying now, but okay, I will say it again, that they are subject to access control and privileges as well. Nick, you were saying something?
Yeah, a question from my side. I was wondering so in this case, unless you changed it and I didn't notice, you selected application JSON, right, for the format?
Yes.
And then what came back was rendered as a nice table. So what magic is going on there, to transform? I can imagine perhaps there's nested content within the JSON, etc. What's going on there, and can we override it? Can we control it? Yeah.
Yeah, you were absolutely right. It is magic. In a way, we do a lot of stuff automatically. And indeed, you guessed it correctly. We did unnesting of the JSON structure in order to represent the results in a tabular manner. So this does not work for all types of responses. The way we do it is there are a lot of heuristics that we use to determine the proper level of unnesting, because as you can guess, there could be multiple nested collections in one JSON document, so it's not canonical. But we do try to do the best jobs in order to properly import JSON as a document. For things when we want to do custom processing, it has to be done slightly differently. So we can still use that method to return a string, and then we can use the transformation to pretty much do whatever you want with that string, including running custom JavaScript code.
Cool, thanks.
Yeah, also there is an ability to intercept the results of the queries using the JavaScript API. So there are multiple knobs that we can turn in order to get exactly what we want on different levels of customization. But yeah, great question. Yeah, we do have this little sort of magical transformations quite often. Okay. So next thing that I want to mention is functions and scripts that serve as data sources, essentially as something that generates data that we look at. And either functions or scripts could be executed differently, and they from different places, but they also could be executed either in the browser or on a server or somewhere. So I'll give you a couple of different examples by going to functions and exploring our functions. So one of the functions that we use often is just a function that returns a test data set. So this executes in the browser. It doesn't list the parameter types, but I just know them. So I want the type of the demographics data set and say, I don't know, 6,000 rows. You click OK, it's here. Yeah, one way to start with the data. Again, everything that you saw today, except for drag and dropping the file from the file system, is replayable. So behind the scenes, if I open if I open not settings, but console, there is a macro generated that is capable of replaying that particular function. So it's always possible to include it in your dashboard as a data generation step, which could be dynamic. Another option to use function, well, it's still technically a function, it just lives in a different place in the UI, is a script, which could be pretty much anything written in Python, R, Julia, JavaScript. More languages are coming. For instance, I think we had, right. So this particular script will mutate a molecule and will show us different mutations of the source molecule. I think it's written in Python. Yeah, let's execute it. Again, UI for the parameters is being generated automatically, so let's mutate that molecule with one step. So probably defaults are good. In this case, it executed on a server. So for some reason, it did not pick up the structures. I'm not sure exactly. But it did return the data set. So the data set is correct, and that's the result of executing a Python function on a server. Yeah, and yeah, by the way, yeah, Walter, that thing could be applicable to the projects we've been working together. Yeah, we'll take it offline.
Yeah, no problem. One question on this is, so you're going to have cases where different scripts use a different Python environments. So how will you support that?
Right. We covered it, I think, in the previous session. So essentially, there is a way to specify the conda environment that the particular script could be executed in. Yeah, we support
right on the metadata.
Yes, exactly.
Okay, that's good.
Yeah, I'll send you the examples for that. We have it in our public repository, but inside the company as well.
Okay.
All right, and yeah. Again, these things, if we open the dataset, I think I forgot to, let's run it again. I closed it. Every time we can click on a table and it becomes a generation script. So this particular case, oops, I don't see it for some reason, but it should be there. And this generation script is getting used when the data sources, well, when the data tables get re-instantiated. So this is a basis for developing dashboards using our platform. I'll give just one short example because this is a big topic which we don't have time to cover in details today. But let's go to, for instance, a database, some Postgres database, for instance, Northwind. Let's run some queries that returns presumably employees. Indeed, we got some employees. We can visualize it in different manner. Well, that's a silly visualization, but should have gotten a better example. And then when we go to share the project, what we have currently, so we would go to the share screen. This is what we have currently in the workspace. We would click on the upload button. And for some reason, it's not here. Okay.
I guess the best way is just to refresh the page.
Okay, I think I missed one step. So, sorry, let's do it again. I think and we would upload it. So which page do we refresh, Alexander?
Browser page. I think there was some bug that.
Okay, let's try to do that. Okay, attempt number 3. Oh yeah, by the way, as we refreshed the page, accidentally we showcased another feature, which is sharing the queries by URL. So when we refreshed it, it re-executed the query. So let's add some silly visualizations, and I hope this time it will work when we do upload, and it did not work for some reason. What should have been here and what was there an hour ago is a checkbox offering to sync the data. And when you turn it on next to the table, it shows exactly which steps were used to execute it. And when the checkbox is on, the data itself does not get saved with the project. But instead, when a user opens the project, the query gets executed and you get the latest view of the data.
Andrew, if you don't mind, I can show it because it's working on my screen.
Okay, yeah, show it, but I think probably people remember, believe us, but yeah, let's prove it.
Yes. Yeah,
we were not going to show a lot of it today, just to briefly mention it, yeah, that's the
so yes, data sync is turned on, and it automatically added connection and query to the project. And if I save it, and then close all and open it again, it opens the same table and refreshes the data. I forgot to add visualization, but that is the case. Yes, the data are being refreshed.
Mm-hmm. Yeah, thank you, Alexander. Yeah, there will be another session devoted to dashboards and a different way to visualize, share the data, and control exactly what gets retrieved from where and what gets shared with whom. But yeah, that's the idea. Any questions regarding that? Mm-hmm. All right. Great. So at this point, we would like to transition to our section where we would that is devoted to developers. So Vasily will explain different stuff that we mentioned today, including the way we define database connectors and some JavaScript APIs. So everyone is more than welcome to stay, but there will be probably a lot of technical content, just a warning. So Vasily, please take control.
Okay. So, do you see my screen?
Yes.
Okay. So let's start from the our public repository where we shared our JS API. So everything that Alexander and Andrew showed you today can be executable from the JavaScript API. And the main interesting thing that everything in Datagrok is a function. So the calls of the query scripts and functions are pretty similar. So we divided in two different sections in the API, only because functions and queries have some minor difference. So for the data, we have data, and let me find it, like table query. So it's pretty simple, just query the data. And for function and scripts, we have other section called functions, and there we have some ways to call the script and call the function with parameters. Scripts, it means that we will call the Grok script that we expose to the console in the platform. And so let's start with some examples. And first of all, again, I think I should explain how we can store the queries and connections in packages. So an easy way to create connections from the UI, like Andrew showed us. So we create an add query or add connection. But for developers, it's not the way. It should be something in a Git repository. So in each package can contain folders that called connections and queries, where you can store your settings. For example, we have connections to the two databases. It's a Datagrok and test tracking. So there we should explain in a JSON format all parameters of the query that we have, or the connection. Or for the queries, we have a little bit different format. It's a SQL, but it's separated with some text tag and parameters. I think everybody's remember that Andrew showed us today the parameterized queries. So there's a lot of queries. Then we can create the small examples of. So the JavaScript API can be written inside the packages, or it can be executed inside the platform directly. What the way we can use, we can create a new JavaScript file. And so let's start, for example, with working with the file system and call the table from the files. For example, we have the files connections, and there we have two queries, three queries. So I will call the products. Let me switch to the template, and I will copy paste there. So what we have there, it's Grok API, data section, and query. There we put the name of the query with the direct namespace for it, and it works asynchronously, and then it returns the table that we will open in the platform. So it's pretty simple. And run, and okay, it works. So we get the file from the it's a CSV file with the products content. And let's back to the template. So then we can call the something more complex. It's the query for the PostgreSQL. So the query that we call orders, and it has a lot of parameters. So it will take some time to show. Okay, so just replace with the other call that is pretty similar. So for the Datagrok platform, the queries to the file connectors, file shares, is completely the same as calling the SQL databases. So I just add more parameters and name of other query and add this table to the Datagrok. And okay, so it also works. It returns only one string. And so, in one more interesting thing that the calls to the web services are completely the same, and so it also queries. It also more lines. So we can what I want to execute there is the web services, the AirNow connection, and focus by the zip code. There are 4 parameters, and then we the parameters. It's a weather in Washington, 25 miles around, and just open in view. Sure.
Yeah, Vasily, yeah, I just also wanted to mention, we don't have this feature right now, but it's in our nearest plans. So for every function that you see on the screen visually and every execution that gets logged, there will be a possibility to automatically produce the JavaScript code that would generate it, so that it will be super easy to do what you want in Datagrok and immediately just copy paste the corresponding code to your JavaScript application code. This will simplify things like that.
Okay, great function. So the next step is execution of the scripts that consume the data. So let's open the example that I prepared. So it's scripts, and I will call the Kolmogorov-Smirnov test. It's a function that consumes 2 columns, the table, and returns the simple p-value of the data.
And it's written in R.
Yeah, it's written in R. So let's put the simple snippet. So I will use 2 approaches there. So I get the table from the data query that gets data from the file from project.csv that I showed before, and then it calls the script with the parameters. And I will use 2 columns, unit price and units in stocks, that I want to test. And then I will show the information in the balloon. Okay, it works. And we have p-value around 0.0 So, so there is no relations between 2 columns, but it works. Yeah. And it's really simple from the JavaScript developer point of view to execute our queries and use the data. And do you have any questions about this topic? Okay, so I can move to other topics that Andrew explains a little bit before. It's writing a custom connectors for the databases. So for these purposes, we have the connectors. This is the service that we called Grok Connect. That's allowed you to connect to any database that has the JDBC drivers to connect. So it's written on Java and uses JDBC technology. And to create the new the connector in our Grok service is simple. You can just write some wrappers for the JDBC driver, put JDBC driver there, or put it in a PAM file. If it deployed in a Maven repositories. And then what you need is to create the description of the connection strings and parameters that provider should expose to the UI. And for example, let's look into Teradata data provider. So the code is really simple. There we have some sections that returns the parameters of the provider. It's a default template, connection template, default credentials template, and it can browse schema. What we have there, it should just combining the parameters of the connection. What customization we have there? The Teradata should has the special SSL parameter that called not usual way. We should put it there, and then we should provide.
I apologize. We are almost at the time limit, so people will start dropping off in probably a few seconds. I already see the number reducing. So yeah, I think they got the idea of it. So we do provide a lot of connections out of the box, and if there is anything exotic or non-standard, you have an option to either enhancing our contributing to our open source project, or taking this project and deploying it on your premises in a different manner if for some instance you don't want this provider to be public. So it's completely open, and there are multiple choices. Yeah, as I said, we are running out of time. We'll be happy to answer any final question in the last minute. Okay, so then, yeah, thank you for attending. It was good to see everyone. I hope to see you again next time in 2 weeks. We'll send an agenda in a couple of days. Yeah, thank you.
Thank you.
Thank you.
Have a good weekend.
Thank you. Bye.